Today we're going to do a little bit of a different video. It's called a paper slide video. We're going to talk about exponents and roots. And again, remember, exponents are the numbers up here. Alright, 3 squared, the exponent's 2. Negative 2 raised to the negative 3. Negative 3 is the exponent. X to the 7th, that's the exponent. And we're going to talk about roots. And roots are the radicals, like the square root of 9, the radical, square root of 7. The cube root of 8, the 12th root of 7. And a paper slide video is something that you guys can do as we get further on and we are doing our own videos. So let's start with why is this even needed? And it comes down to what if something doubles? What if zombies are doubling? How many zombies would there be if you started with 2 and they were doubling every day and it'd be at 6? And there's a couple ways to do that. If there's not many zombies around, you probably have time to write it out. But there are zombies. And that's the big thing about exponents. It's a shortcut. It's 2 to the 6th power does it. And 2 caret hat is what that is called here, 6, or 2 y to the x button 6. Either way, it's the value of 32 zombies if they start doubling. An exponent only reaches one spot to the left, and that's a big deal and something I want to talk about. So if I have 2 times 4 squared, shown here on the left side, you'll see that we handle the 4 squared first. Exponents before multiplication in our order of operations. And 4 squared is 4 times 4, which is 16. Then we multiply. Likewise, over here I have the opposite of 3 squared, or negative 3 squared. Well, the exponent doesn't reach the negative this time. It only reaches the 3, which gives us a result of negative 9. But remember, parentheses are one spot. So when I see the quantity negative 3 to the 2nd power, the square actually touches the parentheses, meaning to do the parentheses twice because it's one thing. Now if I do the math here, I get negative negative. 3 times 3 is 9, so I get a positive 9. So we have a method now for exponents going down the page. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. But how do we show 16 is 2 times itself 4 times? How do we go backwards? We have downstream right now shown. How do we go upstream? And that's where roots come in. And that's often the misunderstood part of exponents. 2 to the 4th equals 16. Well, the way we say that the 4th root of 16 is 2 is we use an index. That would be the exponent on the other problem. We use the radical to say we're not going to multiply up, we're going to find out what it is. And then we have the radicand, which is not as important. I highlighted. We'll often say index or root or radical. But what if there isn't an index on it? And we've done these problems. We have a square root. And remember the word square. That's a two-dimensional shape. So when there is no index shown, it is understood to be 2. And so if you have the square root of 16, what times what makes 16? 4, or 4 to the 2 power equals 16. You can see kind of a circle there. So they're partners. The way I always like to think of it as we practice at it, and I have 3 examples here. If I start on the left here, I have negative 3 quantity to the 3rd, which means negative 3 times itself 3 times. And again, odd exponent and a negative number inside parentheses would be negative. We ended up with negative 27. So if negative 27 is the radicand inside, and we have an exponent of 3 for an index of 3, it has to be that base number, negative 3. Now, the next problem's a little easier. We've got 2 cubed is 8. So what's the cube root of 8? 2. And you can see the relationship here. And finally, I show 5 squared is 25, and the square root of 25 is 5. It's important to realize that order of operation is here. So I included it all here. And it's also important to realize we have to handle radicals with our exponents. So you see here in the first step, I take care of the exponents. The opposite of 2 squared, negative 2 times 2. And I didn't do anything with the minus 4 times negative 3. And I took care of, here's this negative sign, and then I did the quantity negative 2 squared twice, minus, and then what is the cube root of negative 27? Well, remember from our last slide, right here in the first one, the cube root of negative 27 is negative 3. And now I finished doing the exponents. 2 times 2 is 4, so negative 2 squared is negative 4, plus negative 4 times negative 3, plus negative 2 times negative 2 is positive 4, plus this negative is the front here, and the cube root of negative 27 is negative 3. Now I handle my multiplication. Negative 4 plus 12 plus negative 4, negative 3 becomes positive 3. And since I put addition signs in, now it's all addition. And I can simply do the addition and get to the result of 7. Finally, the last thing we can think of is we don't have to have it written out as a numerical expression. It can be an algebraic expression which we evaluate. And here's a quantity x squared y minus y cubed. And again, I always start with replacing the variable with parentheses, because then we see that x squared is negative 2 squared. And again, even exponent is going to result in a positive number. And since the other one has an odd exponent, y cubed, and I put in negative 3, I'm going to get a negative number. But again, I plug in x, y, and y, because that's the variable shown on the top. X squared is 4, negative 3 stays, negative 3 cubed, negative, negative, negative. 3 negatives make a negative 27. Now we multiply in our order of operations. 4 times negative 3 make negative 12. Negative 12, and then minus a minus is a positive, negative 12 plus 27, and I get 15. And I show the exponents being multiplied over here, and I just show the results over here. Again, exponents and roots are like partners in crime. They're PICs. So again, practice this skill, and remember, we have exponents, which are the powers, and we have indexed roots and radicals.